pedagogical breakdown in the skills required to solve these things. So having evals that are representative of those skill sets, that break things down and are able to show when the models are just lucky versus when the models are actually hill climbing being good, is useful for a range of different things. It's useful for actually getting the models to be smarter at this, but it's also useful at highlighting when a model might possess the skills to do something concerning, and when we might need to add additional mitigations to models because of that. So having that resolution of skill composition is critical. And in terms of the environments, having runnable, realistic environments that have that are representative of the complexity of the real world is important. Being able to run these and reset them and be in that same environment again without without the environment changing and without adding ambiguity to the training environment there is important. So having complex environments with the ability to reset them and having easy access into them so that the models can participate in them. Having a good grading criteria, figuring out how you would grade whether or not a model's doing well at a task is important. Tool orchestration. We're finding that, like I said earlier, reasoning and tool use are some of the most important things moving defensive cybersecurity forward. And we're working really heavily on the reasoning side for cybersecurity, but the tool orchestration and tool use is something that the community can help with as well. Building AI capable and native tools that our models can use easily, having documentation that the models can learn from, and effectively making it possible for the models to use the tools out there to streamline their own work and turbocharge their own efforts so that they can turbocharge defenders' efforts as well. And then finally, contamination and reproducibility. Contamination is a really big thing. If you publish an eval set online and it's scraped and incorporated into training data, it's no longer as powerful as if it's held out and kept back. So having the ability to create training environments that are potentially unique each time or have variability potentially mitigates that. Also holding out eval sets also helps that cause. So kind of wrapping up briefly, and I'm mindful of the time as well. Why are we doing all this? We're doing this because the world is slightly scary in some regards with respect to software security, with cybersecurity. There's been, what, 40,000 CVEs reported this last year, and that number is growing. We need to mitigate software security. And if we can mitigate software security, if we can mitigate network security, if we can understand how to handle data more privately, et cetera, and use LLMs to turbocharge those efforts, everybody's safer. You don't have people falling for scams necessarily, or having their computers hacked, or getting a letter in the mail saying that all their data has been stolen because we had a data breach. This stuff matters, and it's not just for the people involved in cybersecurity. It's not just for people that know how to code and are working on digital products. It literally affects every single person on this planet right now. And if we want to make life better for a lot of people, making robust, secure systems and potentially using AI to do it is a strong way to get that done. And so we hope that the community will figure out a way how to work together to build better evals, to better understand the capabilities of models, to help us with realistic problem sets and environments, et cetera, because that's how we move the ball forward in advancing this cause. So I'll wrap it up there, mindful of time.
Thank you so much, Ian. We have some questions. The first question is, as you mentioned, AI capabilities are really like rapidly increasing. And given this, evaluation is really important to evaluate the AI model's capability like more accurately. And then because the workshop is about cybersecurity, and so I have a question, like, do you have some thoughts on what kind of cybersecurity benchmarks are urgently needed the most? For example, you mentioned some issues of the current benchmark, such as contamination and reproducibility, the issues. But like beyond that, like what kind of like cybersecurity benchmark, including like task, like are urgently needed? Like you have a thought about that?
Yeah, so our team is focused with the announcement of Aardvark. This is kind of evident as well, but our team is focused largely on code security to start with.
Mm,
Um, the the focus areas in cybersecurity are broad, and you can also focus on network security. You can focus on um, scam detection. You can focus on privacy. You can focus on literally any of these areas. Um, we felt that code security was the largest bang for the buck for
mm,
initial research, but all of these areas are critical. And if somebody wants to make a huge contribution, tackling one of them that the models don't really do that great of a job at right now is a way to do that. But doing that in a way that follows a lot of the guidance that I just said earlier, meaning it's an environment that can easily be stood up, that's reproducible, that has an easy entry point for the model to use, and has a grader attached to it on the inside, um, preferably a Dockerized container. Making it easy to plug and play these evals in is is the easiest way how to get them used and how to make sure that they're incorporated into
mm.
model benchmarking and potentially training as well.
Mm. Okay, sounds good. Yeah, so because the time is almost like off, so given this, we can move on to the last the speaker. The last speaker is the Joshua Sachs. He's the AI security tech lead at Meta. And Joshua, take it away, please.
Thanks. Here, one second. Let me share my slides.
Sure.
Uh, sorry, one second. Okay, I'm assuming you guys can see these. Speak up.
Yes. Yeah, I
Okay.
can see your slide.
Thanks, Eugene. Hi. Okay, I'm Josh, and I work on AI security at Meta. And my talk today is about the roadmap to achieving AI security automation for defenders. So I have like a lot of slides here, so I'm going to talk very fast, but hopefully I'll be intelligible. So first, I want to define my terms a little bit. So by cyber autonomy, I'm talking about a broad set of capabilities that spans a very large and diverse sort of technical tent. So here's a tree map of the size of the varying sort of submarkets within the cybersecurity market, just as a way of sort of thinking about the scope that we'll need to automate as we look to automate cybersecurity with AI. So it's not just finding bugs and it's not just finding and fixing bugs in code, right? It's also monitoring all the network traffic that edge devices and enterprises experience. It's also it's also identifying like access management issues and compromise in cloud deployments. It's also endpoint security, etc. So there's a whole lot of different types of sorry, let me mute my work messages. Okay, there we go. Yeah, there's a really diverse set of services sort of under this tent, and all of them, I think, should be seen as in scope for automation. And by AI, I just want to ground this. I really mean machine learning models that basically can do what you train them to do. So I'm talking about LLMs here. Can generalize to some other things that you didn't train them to do. But then if you didn't train them to do certain things, like for example, agentically browse your cloud access permissions and identify issues and autonomously fix them, my expectation and my prior is that you can't expect the LLMs to actually accomplish those things. And so, okay, with those two definitions in hand, I think that we're not as far along as some of my colleagues think towards true cyber autonomy across all of those different areas. But I do think that I do think there are a set of technologies that can allow us to make like really dramatic progress over the next few years, and I think most of all, agentic coding sort of paves the way. So here's a slide from, I think I'm not picking on OpenAI here, but I think it's a good example, like the OpenAI GPT-5 system card showing progress at an AI agent agentically hacking a set of cyber ranges. And you can see that we haven't made a huge amount of progress in getting LLMs to do this. And then here's the famous meter plot where we see that there's an exponential increase in the ability of LLMs to, at least half the time solve coding challenges of progressive complexity, and that's sort of going up exponentially. And I don't think, so there's been a ton of progress in areas that we've focused on, like coding, and less progress in areas where I think justly the big AI labs have not focused on building sort of agentic capabilities. But I think that the set of technical tools that are being used to hill climb agentic coding capabilities, so pre-training, supervised tuning, where we use expert data to train the models to behave agentically, thanks to expert contractors who are producing that data, and then reinforcement learning within software engineering environments. I think that sort of recipe at a high level, I think is going to be very useful for automating cyber, and I think the defenders are going to need to do that first. Yeah, so I think adversaries are going to start building these capabilities, and I think defenders have to do that too. I think that we really need to set our sights in the defender community beyond co-pilots and aim at true autonomy. So it's not enough just to find some potential bugs in code. We also have to prove them out, like the previous presentations demonstrated, and then eventually actually fix them. It's not enough just to find some hypothetical access management issues and in the enterprise's access management deployment, we need enough confidence that we can actually entrust that kind of agency to an AI over a human. I think we have a long road to get there, but I think that needs to be the goal. And I think what we need to aim for is more like Waymo in the path that autonomous vehicles have traveled, and less like Clippy, like an assistant that sort of sits alongside you and serves as a kind of convenience feature, or maybe increases your productivity by 5 or 10%. So we need to set our sights much higher than that. Okay, so I just wanted to give some theses about how we work towards meaningful autonomy. So first, I think we need to take the possibility that we could, achieve meaningful levels of autonomy seriously over the next few years, and that our adversaries could too. So we need to work with a sense of urgency. Like I said before, I think that there are disciplines within AI that have made much more progress towards autonomy, and so I think we need to take inspiration and guidance from those disciplines, for example, like coding and research agents. I also think that we need to start taking evals much more seriously in security. So we don't have sort of like ImageNet quality evals across the whole range of security disciplines that I showed on the first slide. And I think that's a blocker and a friction point to realizing our autonomy goals. I don't think, and I'm going to argue this in more depth later, but I don't think prompting general purpose LLMs is going to get us there. I think it'll get us there in terms of assistance and some level of some sort of progress around some autonomy verticals, but I don't think that it's going to get us all the way there. And so I think we're going to need to look at actually fine-tuning LLMs for the security verticals. And then I think we're going to need to rethink cybersecurity ultimately is a very process-oriented discipline that involves lots of stakeholders coordinating and working together. Those processes were invented for the pre-AI era, and I think we're going to need to rethink the way in which we structure teams and the way in which we actually perform cybersecurity as organizations responsible for defending people's privacy and security. I think this is a harder problem than other areas of machine learning. Enterprises, so AI, the lifeblood of AI is data, and enterprises keep their data private. Lifeblood of AI is data, and attackers obviously keep their data private. I think the big AI labs are incentivized, and this is not a critique, it's just sort of the game theory and the economics of the situation, to dominate the larger markets, like general chatbot use cases and coding use cases. And so there's just less funding for security, and these are all challenges also to realizing these capabilities. I'm going to skip over this slide, but I'll go into some ways that I think we can address these challenges. Okay, so now I want to give the kind of maturity model that we're using at Meta around thinking about how to begin to solve for autonomy. lots of folks at Meta are building AI agents, as at many of your organizations as well, for cybersecurity. And usually the way this process starts is we start experimenting with general purpose LLMs to see if they can solve a given security problem. And we don't really have evals, or if we do have evals, it's like a handful of examples, and we get the agent working sort of based on vibes. This is sort of the crawl state. I would say most agents for security are sort of in this state of maturity right now. The inevitable problem here, and I think that even in academic literature, we are still often in this place, although thanks to work like the work at Don Song's lab, for example, on like evals like Cybench and CyberGem, I think we're making a tiny bit of progress. The current state often though is like there are lots of different evals. None of them are good enough to be canonical. And so you get lots of different papers published, and they're based on different evals, and the results are incommensurate. What we need is something much more like ImageNet, which allowed the computer vision community to sort of hill climb, like one sort of eval operating system and compare results across papers. And we don't have that for like the vast majority of cyber disciplines. And within organizations, we often don't have evals. Like within big companies like Meta and Google and this kind of thing, they're also we haven't solved that problem also. Okay, so oftentimes I think folks in the cyber community are attracted to sort of like doing this like fun kind of stuff, like building complicated multi-agent frameworks that coordinate a bunch of different LLMs and use, like novel MCP tools and RAG and this kind of thing. Actually, oftentimes it's much higher leverage to do the sort of boring work of building like very good evals, which then allow AI approaches to be compared and allow teams to actually hill climb results and get better and better results. Okay, so that's the sort of crawl state. In the crawl state, we don't really have good evals, and the sort of exit criteria for the crawl state are to build them so that we actually have like an empirical hill to climb. In the walk state, at least the way we're thinking about it at Meta, we still aren't fine-tuning LLMs, but we have really good evals, and we be like really good offline evals, so that we can gauge how good our systems are, and we're sort of beginning to build online evals. And so what this gets us is the ability to say, change your system prompts and then actually know if that improved your system or not, right? I think this is like this is a simple thing, but it's like, this is a huge problem across AI security is many of us are in the state where we can't change a prompt and really know with confidence and in a way that's uncontroversial, like within our team or our community, whether that was good or bad, right? And so in this walk state, we've sort of finally solved that problem. Now, like the inevitable problem with, I think, being in this walk state, if you're using sort of generic general purpose LLMs, is that you are just hoping that the general purpose LLMs that you're using were trained on data that will generalize to your problem. And anybody who's actually tried to get LLMs to produce like security business value within large organizations, like probably knows that like the amount of futzing you have to do with an LLM to sort of like understand your organization's private data or legacy code or private documents if you're doing stuff like detecting data exfiltration. That's a frustrating place to be. And so ultimately you do need to, I think in many cases, not all cases, but in many cases, you need to fine tune LLMs on your own data. And that's because LLMs still have this property, right? They're still machine learning models. They still do really well on in distribution data. They do an amazing job of generalizing out of distribution, but that's limited, right? And then there's a universe of things that LLMs cannot do yet. Okay, and then the final sort of most mature stage that we're sort of using to define our maturity model at Meta is this run state where we're really in the kind of operating model where we have offline evals that we trust that allow us to hill climb efficacy. We have online evals that allow us to monitor performance in production on like the actual production distribution. We can do A/B testing. We also have training data, and we're, at least in many cases, we're fine-tuning our models, and we're in a kind of mature, we're in a mature state in this run state. And I think it's really urgent that across security we get to this run state for the reasons that Ian and Newton mentioned before. We don't have the luxury of like sort of slowly and incrementally like realizing autonomous defensive security. We are racing against adversaries who we should expect are developing their own autonomous capabilities. So we need to figure out how, like, and this is a hard problem because security is such a complicated discipline. I mean, there's like such a big technical difference between detecting data exfiltration versus, you know, doing tool calls into fuzzers and like formal methods tools to analyze code. But we have to solve all of those problems in order to compete with our adversaries. Okay, I want to talk a little bit about data foundations now. So like, it's interesting to me that that there's a huge surge of interest and also progress in getting LLMs to find and prove and fix bugs in code. And I think the reason why we're seeing that is that the big labs have invested very heavily in getting very high quality data for agentic coding. Not so much agentic code security, but agentic coding. And the investment's been pretty remarkable, right? So here's like an estimate of how much the various labs have invested. So, you know, in this estimate, this is all based on public data, so there's like a wide confidence interval here, but you know, Google has invested like $100 million in paying contractors to create custom supervised fine-tuning coding data, and other labs have invested tens of millions of dollars as well. And I think we're going to need to do the same. So we're going to need to find ways of doing this in cybersecurity also. Like, I don't think we're going to get, so I think all of this investment has helped with AI security, like code security capabilities. I'm not sure it's going to help us solve like cloud access management, for example, or malware detection, or detecting living off the land attacks when an attacker is sort of midway through their kill chain. I think we're going to need separate data to solve those problems. And we can't rely on sort of the downstream effects of these coding investments there. I think we're going to need to build lots, and we're going to need to figure out how to build lots and lots of RL environments for LLMs. You know, the big labs have been investing for the last you know, 18 to 24 months, I'd say, in building very good and diverse coding environments. But we're going to do the same thing for areas of cyber that are sort of outside of the code security domain. I think CyberGem is a great example. I mean, this is in the code security space, but I think it's a great example of like an early entry in this process. But we're gonna need like 100x more across like many different cyber disciplines. And there's just like a vast difference between doing like the RL step in LLM post training against a given vertical and not. So I mean, here's just a screenshot from the R1 paper earlier this year where they show, you know, they went from 20% AI ME accuracy to like 85% after doing RL training. I think we're going to see that. I think we're going to see similar dramatic step functions in cyber autonomy, but we need to build the environments to actually do it. And I think this is the way we sort of get out of just like futzing with prompts and hoping the general purpose models sort of solve our problems for us. Because I think the general purpose models will solve some of our problems, but many of them we're going to have to solve ourselves within the AI security community. Okay, so I only have a few more minutes, so I'm going to go really fast through the last few slides. So I also think so I think that transforming cybersecurity with AI is as much an organizational sociology problem as it is a technical problem. So it's a kind of socio-technical problem where we need to rethink the processes that we use. So for example, think of like a security operations center as a sort of bundle of human processes coupled with like technological tools that mediate those processes, and then like an org chart and a whole bunch of practices that sort of maintain that org at steady state in terms of hiring and the kind of people that we hire. All of that I think is going to need to transform thanks to AI. I think we need to be thinking about those more sort of organizational sociology transformations like in tandem as with the technology changes that we're going to need to implement. Yeah, so it'll take just as much experimentation, and I don't think we can design this whole thing waterfall style top down. I think we're going to need to, all the folks here working in cybersecurity and AI security, you know, I think we're going to need to experiment here and sort of share learnings as a community and sort of learn how to structure the sort of AI security organizations of the future. Yeah, so you know, I think the roles are going to change, the org charts are going to change, and then the processes are going to change. So okay. Wrapping up. So I think that I think that we are on a path towards achieving significant autonomy in AI security, but I think our agency is going to play a critical role in actually getting a good outcome. So I think we can expect that attackers are going to use the technical tools that are now in the public domain around how to train LLMs to solve like specialized agentic problems. So for example, attacking a network and sort of walking a kill chain. I think that as defenders, we're going to have to move faster than them in order to make sure that there's a good outcome in AI security. There's a huge opportunity here. This is the most exciting time in my like 20-year-long career in cybersecurity. Looking forward to see what we can do together. No, I'll stop there.
Thank you so much, Joshua. We have some questions. And first, you actually claimed we need significant autonomy and labor productivity gains as fast as possible. Otherwise, the adversary wins. So, would you mean that significant autonomy and labor productivity gains will not benefit the adversary significantly? Or can you explain more, like how you think the significant autonomy and labor productivity gains like benefit more the defenders than attackers?
Yeah, yeah. So I'm not sure I totally understood the question, but like if I understand correctly, I'm not taking a position on who's going to benefit more AI. I guess insofar as I'm taking a position, I'm just saying that I think that attackers and defenders both have the tools. I think basically like the current training, the high level training recipe that we have for LLMs, where we do pre-training and then like to roughly speaking, we do pre-training and then we do sort of supervised fine tuning and then we do reinforcement learning. I think at this point we have good evidence that can be used to achieve significant intelligence and autonomy. But I don't think we're going to get that for free in cybersecurity. I think we're going to have to build it by building our own RL environments, building our own like high quality supervised fine tuning data sets. And I think like basically the race is on to see who does that faster, bad actors or good actors. There's just so I don't know what the outcome's going to be, but I know there's urgency for defenders to build sort of our side of that.
Got it. Understood. Yeah, I agree. And another question is, okay, so you mentioned that many companies are now investing in coding related data, like to get like a better like model. And do you think there is a way to reduce the cost of generating good coding related data? Like for example, we can use LLM or other AI models.
Yeah, yeah. So the question is like, how can we get good? So is the idea? So I think the question is how do we get cheap, like
Yeah, reducing the cost.
like security data, like for
Yeah.
Yeah. I mean, I think that some of it's just going to be expensive, but so I think that the labs and also cybersecurity companies are going to need to pay the cost of getting like high quality, you know, high quality data from cyber experts, just in the same way we paid for. I mean, folks here probably know, right? There's a whole industry around producing high quality expert data in many, many different domains. And I think in domains where there's the most of it, which like I think coding is a great example. We've seen huge progress. So I think we just are going to need to pay the cost in cyber, and so that's a problem for the big companies and venture-backed firms and stuff to sort of, and also grant funding agencies and this kind of thing, to figure out. I think like an optimistic thing I'll say is that reinforcement learning is like dramatically more data efficient than supervised fine tuning. So if we can figure out ways, I don't think this applies to every cyber problem, but I think it does to some. I think we can figure out ways to build RL environments that model real world problems in a good enough way. That's great because people have probably seen the papers showing how data efficient RL is. It's like orders more data efficient than SFT. So I think there's some hope there, and in sort of identifying problems that can be RL models through environments that we build.
Yes, sounds good. Yeah, it's really useful. And yeah, last question is actually it's the same question that I asked the Ian. Do you have some thoughts like on what kind of cybersecurity benchmarks or tasks are urgently needed the most currently?
Yeah, good question. So I think these are very hard to. I think where the most value is, or like the sort of so some obvious things, but I think will be uncontroversial here. And so investigating alerts, so like an enormous amount of human labor goes into the manual process of like seeing a security alert and then investigating to see if it's a true positive. Um, I think, and there are many big companies and also AI security startups and larger AI security companies who are trying to build alert investigation automation workflows. But I think we're in that kind of crawl state where if somebody comes to me and says, "Oh, I have this alert investigation system, it works great," it's just like, trust me, bro. Like, I mean, that's the level of evidence that they're providing, and there's no evals that actually can give a kind of a leaderboard over who's doing best. So I think that's a big priority. Um, but I don't know how to solve that problem given how much private data is involved. I've got some ideas, but if anybody can solve that problem, I think that would be of enormous value to both the academic and industry and community. And then I think the work that folks here are doing on like cyber gym and that kind of thing, I think that's like super valuable also, because even though I think bug finding and fixing is the most mature area of AI security right now, I still actually think we've got some distance to travel before we have like an ImageNet quality canonical, sort of set of evals. So I think that's useful too. Anyways, those are just some thoughts.
Yeah, I agree, because like many current cybersecurity benchmark focus on like different tasks. So yeah, actually to address this issue, we also like built some observatory where we collect all existing like cybersecurity benchmark, and then by doing so, communities can monitor like different aspects of cybersecurity capability in AI model. So yeah, okay, sounds good. Yeah, thanks for the great talk, Joshua.
Thanks,
And yeah, from now on, we will start the panel discussion among Ian and Newton and Joshua. And actually, before starting with this panel discussion, yeah, let me just tell the announcement to audience. We are now collecting some responses for our like survey to like collect people's opinion on the balance between cyber offense and cyber defense. And we posted this survey link in the YouTube, the chat. So yeah, audience, please feel free to take the survey. After the workshop. And from now on, let's just start our the panel discussion. So first, like each of you are from the frontier labs. So I expect that you have like different experience or different lessons for each of you, the company. And our first question is, have you ever observed an increase in attempt to misuse your models for cyber attacks or malicious purposes? And if so, then what kind of misuse activities did you observe the most? And yeah, maybe we can start with Newton.
Yeah. So I think that's maybe one of the running themes across really all three of our talks is that we've seen, I think, an increase like across the industry as a whole, as just more and more threat actors are experimenting with these models kind of across the board. It's not limited to not necessarily limited to any specific labs models. It is in the attacker's interests really to just like try to expand their portfolio of tools as much as possible. And I think like I was saying in my talk, I think what we know to be true is that attackers are getting increasingly sophisticated with their model usage, that they're experimenting with, like Joshua was saying, that like in some sense they are already in the process of optimizing how to better use models at greater scale. And so I think it's really sort of like what we're seeing is just across the board, across the entire industry of AI labs, that like increasingly complex scaled misuse of models is going to be a major problem moving forward.
Yeah, so you also like observed like increasing activity of misuse for spam or phishing, like because I also like encountered like Anthropic recent blog to this like about the recent misuse activity of cloud model. So like you encounter like some increasing activity of spam or like some phishing using cloud or something like that.
Yeah, so I think like so our safeguard team, like I was saying, I think they sort of try to regularly publish these like threat intel reports of what we view as sort of like particularly interesting cases that we've caught and disrupted. I think like a key part of that is exactly that, ultimately, for better or for worse, I think my colleagues at the other labs probably feel the same, that like safeguards and this whole like sort of trust and safety teams are really going to be a super key part for better or for worse in the next couple of years of really like improving our ability to catch and disrupt these types of operations. Yeah.
Okay. How about Ian? So have you ever observed like in increase in misuse?
Oh, of course. As AI proliferates and people become more aware of all of its different capabilities, and as it becomes better, people are going to start using it for malicious purposes. So internally, we've got several different teams focused on everything from threat actors targeting our systems, and we stop that, and also threat actors using our systems for abuse externally and against other people. The latter, we've reported several cases where, for instance, nation states have used our models to create obfuscated code snippets, to string together multiple different things to create tools and whatnot for their uses. And we've announced and published some of these things, but yeah, nation states and less sophisticated attackers are going to use AI as much as they possibly can, and it's going to be a cat and mouse game. And whether we're able to effectively catch all of them we'll see.
Sounds good. How about Joshua?
Yeah, I probably can't. I'm not like clear to say anything that we haven't published publicly, so I'll just speak in general terms. Yeah, we've observed some of what that my colleagues just described. I mean, a lot of our models, as everybody knows here, a lot of our models are open source, and we've also observed that attackers, like there's some cases where attackers have fine-tuned them, to use them maliciously. We've also observed like Cisco has now a line of models based on Llama 3 that are like fine-tuned. I forget what I think like on like 500 million, that kind of order of magnitude, like security specialized tokens, which seem really promising from our perspective also. Yeah, I think this is going to be I think like I don't know, I'd be curious to hear what other folks on the call think, but I feel like this is like, like the first days of COVID or something, and it's like we can't index too much, on like the stories that we have now around attacker use, like because like probably there'll be like a number of qualitative notches that we're going to hit around attacker autonomy here, and we're in like the very beginning. Like that's for my impression is like the practice of offensive cybersecurity and the practice of defense of cybersecurity have been changed a bit, but haven't been like qualitatively like revolutionized yet. So I'm like more thinking about like the next few years than like what we're observing right now.
Yeah, we agree. We all like. I think I believe that all of us are seeing more and more news about attackers misusing AI. Okay, thanks for the answers. And the second question is, how do your internal red teams or adversarial evaluation processes in each company test your models for potential cybersecurity misuse vectors? And can we start with the Newton?
Yeah, happy to. So I think I sort of alluded to this a little bit in my talk. I think we certainly, I think, have in some sense our classic, like we have our suite of evaluations that we run related to various cyber capabilities for people who are familiar with our responsible scaling policy for a long time. We sort of had these commitments around particular evals that we run, and we're developed for that. We do pre-deployment testing with external partners, and kind of very recent and sort of more recently, in some sense, the mandate of my team was, okay, let's also try to, as much as possible, build out systems that are like as close as possible to the actual mock-ups of like the types of misuse that we're seeing, sort of trying to move away from proxy tasks and more to the real thing. And so for again, very similar evaluation challenges that my colleagues at the other labs discussed, but I think really the big one is we're working hard to develop increasingly sort of facsimiles of the real world misuse that we're concerned about.
I'm just curious, actually, like cybersecurity attacks are really broad, and there can be more new emerging activities over time. And how can we ensure that we actually tested like all of the possible activities?
Yeah, I think this is like an eternal problem in security of how do you make sure you cover your entire risk surface, including the ones that you don't know about. I think a lot of it is just, obviously spending a lot of resources in terms of being diligent across the entire stack of system security. Like my colleagues were saying, it's not just finding all the vulnerabilities in your code. It's making sure that as a whole, your entire system has a good security posture, and it's about really leveraging as much as possible, like the amount of data that we're getting right now about like the TTPs and the signals in the real world of what people are actually using the models for.
Thank you. How about Ian?
Sure. So capabilities are super important, right?
Yes.
Like if something is incapable of doing something, then monitoring it for use in those cases is not as relevant necessarily. So that goes back to the evals discussion as well. We have a preparedness team at OpenAI that if folks look up OpenAI preparedness, you'll find all of our recent documentation on this. And one of the topics we track is cybersecurity and the ability of the models to be used for various actions within the cybersecurity domain. And this is an evolving conversation. And I'm definitely not going to speak to all the details and where we're at right now with all the nuanced thinking underneath it, but looking at evals as a way to understand what skills could be strung together to do various actions with the models is, in my opinion, probably the best way that we can think about this in this group right now. So that again is a call for better evals, more realistic evals, really understanding skills underpinning those evals and benchmarking based on that.
Sounds good. How about you, Sean?
Yeah. So we've been like pretty public about our cyber testing. So we've got like 4 papers. Like the first 3 are like Cybersec eval 1, 2, and 3, and then we've got one called Cybersoc eval, which is like a defender capability eval. Yeah. I mean, so I think I think we all read each other's system cards, right? I think our strategies pretty similar to OpenAI and Anthropic. We're interested in. I think we've all. So I would love to hear my colleagues speak up if they see things differently. But I think we've all sort of converged on a point of view where we're not just like a couple of years ago we were focused on detecting like predicting attacker uplift, and now we're interested in predicting both attacker and defender uplift when we release models, and looking at a more holistic picture where we consider sort of in-lab attacker uplift estimates, in-lab defender uplift estimates, but then also sort of intersect that with our understanding of the threat landscape, so we actually understand how a new model might what marginal benefits that'll provide to attackers and defenders in the actual ecosystem as it stands and where it's going. Yeah, that's the way we're thinking about it right now.
Yeah. Actually, one interesting thought I have in mind just during this conversation is we might just make some optical AI, like the fine-tune to be a bunch of cybersecurity data, and then we can see like what the optical AI are doing, misusing our like different, like some AI system. By doing so, we might like explore what kind of cybersecurity the misuse can emerge or something like that. It was just one of my thoughts. Okay. Okay, another question is, okay, now, another question is, where do you see the most promising applications of AI in enhancing the cyber defense? Can we start with Newton?
Yeah, this is something I feel I'm pretty enthusiastic about. Joshua was alluding to, I think the strategy that we have at Anthropic is, we are trying to prepare for this world of really like how AI augmented cyber offense, and we think that the best way to fight this is we really want to arm defenders and make defenders as capable as possible, because that's how we see doing it. And that's not just, oh, certainly there's many things that are very what I call like developer coded, like, oh, we find bugs in our code, we fix them, we patch them, this is all great. But again, as my colleagues were alluding to, cybersecurity is way more than this. Even just like SOC tasks of triaging security alerts and doing threat investigation and doing threat intelligence properly and well. All of this is stuff that is really integral to actual good security posture. And so I think initially right now where we're at is we are doing things like vulnerability discovery and patching because that's related to code. And I think that a key part of leveling up our applications is, one, pursuing this more autonomous defensive agents, and two, figuring out how we can deploy AI across the security stack to handle things like SOC, to handle sort of things that maybe are less flashy than just like finding 0 days.
Yeah, thanks for the response. And how about Ian?
Yeah, building on what Newton said, the challenge isn't necessarily starting to get people using the tech. People are already using the tech for the entire stack of defensive cybersecurity capabilities.
Yes.
The challenge that I see right now is that the models are capable of so much more than what people are actually deploying for. And finding ways, and this is across the board, it's not just a cybersecurity problem. This is even in writing and planning and reasoning, all that stuff.
Yes.
So finding ways of getting those applications to the end users in a way that doesn't require far more sophisticated understanding of the cybersecurity domain that they're operating in than that user has is important. So how do you get these defensive capabilities to a small company that maybe doesn't have the expertise in cyber but needs to defend themselves, make their code base more secure, works, defend their users, et cetera. And so that, I think, is the gap right now, is getting the applications of the models in cyber to be more easily integrated into workflows and out there. So I think there's some catching up to do with that, while at the same time improving model capabilities overall for these domains.
Okay, sounds good. Yeah, thanks for the response. How about Joshua?
Yeah, I guess I'd just add, like, I'm assuming that like there's there are a lot of researchers on this call, just given the organizers. I think for the research community, both in industry, those of us who can publish in industry, and then also in academia, I mean, like, to me, by far the highest leverage thing we can be doing is building very good evals that are so good that when somebody does well on them, it'll be like evals that are so good that they sort of uncontroversially index progress in that field. So like Microsoft released a really good eval a few weeks ago. It was based on like sanitized incident data, and where the sort of agentic task needs to be solved is actually sort of like doing a multi-hop like series of queries where the agent like investigates the incident and like finds the attacker in like this big haystack of like sanitized data. Like, I think that's a great example. I mean, that's one example. I think CyberGym is a great example also. Like, there's a lot of good evals out there right now, but it's like, that's just like the very start. And like, I guess I would go back to my ImageNet metaphor. I mean, I think ImageNet had like 1,000x the impact on computer vision than any particular ResNet, implementation, or like, convolution, and like whatever, any particular decoration on the standard convolutional neural network recipe, because it gave the whole community an operating system for like hill climbing, like the image classification problem, and allowed for an enormous amount of innovation. I think we're like sorely lacking that in the research community, and so I think there's just a lot of leverage in building evals. But on top of that, there's lots of other good work to do too.
Sounds good. Okay, so we can move on to the next question. Yeah, so I'm also curious, like, what do you see as the most critical open research problems at the intersection of AI and cybersecurity? Yeah, Newton?
Yeah, I think that in some sense, the most critical problems are I sort of, at a very high level, I bucket this into two areas. One, I think is one that everyone is pretty convinced about, which is just, okay, like in terms of capabilities, how can we try to best differentially accelerate defenders over attackers? And I think like that's the sort of like high level problem. Obviously, there's a bunch of sub problems, but I think figuring that out is really important. And then I think the other part of it is exactly this question of actually like, okay, like how can we actually build these what, again, I think we're very aligned with the idea that yes, we need to pursue a line of like autonomous security defenses. And I think that is just an entire, as I'm sure Joshua appreciates from his talk, like that's an entire research roadmap and multiple sub problems on its own. I sort of view these two as again, at a high level, like really the most critical two problems they have to face, and really two of the problems that we're spending a lot of resources internally at Anthropic working on right now.
Sounds good. Good. Ian?
Yeah, I think right now we're at the phase where we need to just continue to increment on the difficulty of the challenges that we currently are looking at. So going back to my talk earlier, harder evals, more realistic environments, all that stuff. I think there are probably like big research problems that need solving that you could label, but I really think we need to just do a little bit more work first on the complexity of eval data sets first to really scratch at what those research problems are.
Got it. I agree. Joshua?
Yeah, so the question is, what are the most important areas to work on, Eugen?
Yeah, so what do you see as the most critical open research problems at the intersection of AI and cybersecurity?
Yeah. It's such a big question. I don't think I have a very good answer other than
Yeah, it's a really broad
work on evals. Yeah.
Okay. Yeah, and then we have like two questions left, and then these two questions are like actually our organizers are also really curious about your opinion. And the first question is about prediction. So when do you think AI will surpass the human experts in almost like all cybersecurity tasks? Like I believe that because you are from Frontier Lab and that you already believe that AI will someday surpass the human experts in almost all cybersecurity tasks. But here, this question is more like a when. So Newton, can you start?
Yeah, so standard grain of salt. Obviously, cybersecurity tasks is really broad and all that stuff. I think I tend to be maybe more optimistic. I sort of suspect that I think my median guess might be that we're looking at something like 18 months before we're sort of like really surpassing a lot of what I might consider like median performance on cybersecurity tasks.
Sure. And how about Ian?
I think that AI will supercharge humans' abilities in the cybersecurity domain and will lift up people who might lack a lot of the sophisticated skills required to implement cybersecurity. But at this point, we still think that humans should be in the loop in these cases, and human judgment, ethics, values, etc., are critical to maintaining the stability of our world in general. And so answering the question of when AI will surpass humans, I think it's the wrong question. I think the question should be, when will AI be a far more empowering turbocharger of human ability to defend networks, to make a secure global internet, digital world, etc. And I think we're starting to see that already, but I think it goes back to the question of, how do we get this in more people's hands? How do we expose those capabilities to people? And how do we continue improving the model capabilities? And so I think pushing all that forward will solve the problem of, or not solve the problem completely, but will help address cybersecurity in general and turbocharging capabilities.
Okay, thank you. So then you think human anyway always like should be in the like collaboration with AI to solve the cybersecurity task instead of just like AI only AI like AI as a like autonomous agent, AI just doing the cybersecurity task. Is it like correct?
I mean, there's lots of ways to view a human in the loop.
Yeah.
I think at a high level right now, there's a lot of questions that continue to need to be worked out on how humans engage with agents in this domain, and we still need to figure out the answers to that. So I think it'll be an evolution.
Okay, thank you. How about Joshua?
Yeah, okay, yeah, okay. A few thoughts. This is a very interesting question. I mean, so for one, like even in cases where, so a few disjoint points. So like one, even in cases where it appears we've achieved full autonomy, like say like Waymo in San Francisco or something. I mean, there's still like operators in an ops center, who are like, there's like a 1 to 10 ratio, I think, right now between like operators and Waymo cars. And then there's also the things that you'd normally expect a driver to do, like get like I don't know, like change a flat tire, right? Like you still need like a person to come out and do that. So like there's a lot of hidden human labor, even in cases where it feels like we've sort of totally climbed the hill of autonomy. I'm sure that'll continue. I guess to Ian's point, like I'm sure that'll continue to be the case, and really like there's some sense in which like we'll just want to keep sort of like moving that ratio to our advantage, like where like there'll be like a 1 to n ratio, and we just want the n to keep going up. That's one thing. I mean, the other another thing I would say is, yeah, I think this is interesting, like because I think I have a more pessimistic take than Newton. Like, I think that actually maybe not. I'll just say what I think about how close we are. Like, um, so I'm wondering if other people have had the experience of like trying to get an AI agent to do something like approve access management requests like within their organization, and then discover that there's like a local dialect of English that's spoken in our organization that the LLM just like doesn't understand, right? And then so you wind up like tweaking the prompt a million times, right? And then like even when it seems that the LLM does well enough, then there's the sort of organizational friction of like convincing folks that like, yeah, we should turn over this like sensitive decisions like to an LLM, that used to be made by a human. So there's that also. And like that example is for a task that's like highly in distribution for LLMs. It's like basically a document classification task. Like you're taking a bunch of sort of evidence and like having it spit out a binary decision, like should the person have access or not. I mean, that's one example of like where we're at in terms of autonomy. But then there's much more complicated examples, right? Where like, if you really want an LLM to automate what like a code security analyst does, I mean, they're not maybe 10% of the time like they're trying to find bugs in code, right? Like the other part of their time, they're doing like sort of project management stuff, like trying to get people to actually fix the bug. They're like negotiating with like legal and like there's like a whole bunch of other things too, like a lot of hidden labor, right? Like, so I think that makes me a little bit more like I don't want to say pessimistic, but makes my timelines a little bit longer. And then the last thing I would say is that I think we do, like I said in my talk, like I think we do have the technology stack to actually succeed in automating a whole lot right now, but it's going to take a lot of investment around like developing like high quality fine tuning data sets, like developing evals so we can actually build the technology in a mature way, and build in some cases building RL environments. So it's not that like we need some big scientific breakthrough, but in a lot of cases it's just a question of like how fast the industry is going to actually make the investments in those areas.
Okay, sounds good. Yeah, I agree. Okay, there's a last question, and the last question is, who do you think will benefit more from AI between attackers or defenders in the short term and in the long term? Then could you start the Newton?
Yeah, I think my take is maybe not too controversial. I suspect that in the short term, attackers might be advantaged due to what we might view as like deployment issues of really making sure that even small businesses, like Ian was saying, can get access to these types of tooling. But I feel quite optimistic that in the long term, which isn't even necessarily that long, it'll be defender advantaged, and I think a big part of what we as Frontier Labs and certainly Anthropic is trying to do right now is trying to do as much as we possibly can to shrink that timeline of what short term actually means.
Okay. How about Ian?
I think that honestly, I think it's up to all of us. I think it's up to the world to figure out who if we are able to use AI tools to patch all the 0 days in code, and like if we were able to do a mass mobilization right now where we patch literally everything, then the world would be a whole lot safer. But that's not an AI thing necessarily as much as the logistics of deploying it to all these services. So, I mean, this really is it's a bigger question than I'm empowered to answer right now, and it relies on political, economic, and human will forces to get done. But hopefully, it'll be defenders. I think there is a path where defenders will largely benefit from this technology.
Okay, yeah. Thank you. How about Joshua?
Yeah, I mean, wildly speculative, right? It's like very hard to predict the future, especially about complex systems like societies. But I mean, I guess like first principles, right? Like defenders have a lot more flops. Like we have a lot more compute than attackers. Like the world's comprised of like, you know, what 0.01% or probably much less, orders of magnitude less than that, like cyber attackers who are trying to do us harm. Whereas like the whole world's like, you know, runs on compute, right? This is our, you know, coordination and comms infrastructure. So we have a lot more compute than the attackers. And if you imagine sort of in the limit or asymptotically, like, you know, having good intelligence, good security intelligence, you know, be ubiquitous where it lives on every edge device, every phone, have it has a small model, you know, every EC2 or, you know, like cloud instance, like has a small model, and they're all able to reason about the enormous haystack of signals that, you know, we need to process in order to detect attackers. I mean, that seems like a pretty optimistic picture for defenders. But you know, I don't know. It's very hard to predict. So yeah.
Sure. Thank you so much. So yeah, we can end. So thanks again for your great talk and panel discussion, Newton and Ian and Joshua. Thank you so much again.
All right, thank you, Eugene.
Hello. So next, I will host today third session. And in this third session, we have three speakers, Dong-Song, Nicole, and Richard. And first speaker is Dong-Song. Dong-Song is a professor at UC Berkeley and the director at Berkeley RDI. So hello, Professor Dong. You can start your presentation.
Okay,
Hello.
great.
Okay.
Yes, can you? Yeah, thank you, Senior. Okay, great. Yeah, thanks. Thanks everyone, and thanks again everyone for joining the workshop. Yes, my name is Dong Song. I'm a professor in computer science at UC Berkeley, and also a co-director of a campus-wide center called Berkeley Center for Responsible Decentralized Intelligence, RDI, which is co-hosting this workshop. So for my talk, I'll talk about frontier AI in cybersecurity risks, challenges, and future directions. So as we are all excited about the fast advancements in frontier AI, at the same time, we also need to be aware of and pay attention to the different potential risks. So for me personally, I do strongly believe that cybersecurity will be one of the biggest AI risk domains for a number of reasons. First, today attackers already have diverse incentives for attacks, and also attacks are already causing huge damages every year. And with increased AI capabilities, it can significantly reduce attack cost and increase attack scale. And the key question here is, how will frontier AI change the landscape of cybersecurity? In particular, given that AI as a dual-use technology can help both the attacker side and the defender side. And in particular, the key question is, who will AI help more, attackers or defenders? And to answer this question, we need to do comprehensive analysis of the full life cycle of cyber attacks and defenses. Cyber attacks are very complex. An end-to-end cyber attack often goes through multiple stages called the kill chain, and defenses also go through several stages as well. And so my group actually has been the first to investigate using deep learning for in cybersecurity domain, such as binary analysis and vulnerability detection. So almost a decade ago, our earlier work showed that deep learning, even back then, can already reach state of the art in certain cybersecurity tasks, such as binary code similarity detection and vulnerability detection as well. Now, fast forward with the advancement of frontier AI, the AI capabilities in cybersecurity has even further improved. In our recent work, we have conducted in-depth analysis where we surveyed hundreds of papers and articles to analyze the current AI capabilities and impact levels throughout the different attack stages, as well as different defense steps as well. And our work showed that the AI impact today are still mainly limited to for attacks on humans, such as social engineering and phishing attacks. But however, with the recent progress, our work also shows that the cybersecurity landscape is changing very rapidly. In particular, given the recent increase in reasoning and tool-use capabilities of frontier AI and in agentic AI. So here are two examples of our recent work demonstrating this point. That the AI capabilities in cybersecurity today are already getting to a very advanced level. So the first example is our recent work called Bounty Bench, which assembles a benchmark including 40 real-world bug bounties from 25 diverse web systems. These are real-world bug bounties and real-world web systems where web developers put out these monetary rewards to incentivize white hat hackers to help find vulnerabilities and also develop patches. So with our Bounty Bench evaluation work, it shows that today's agents can already solve a significant fraction of these real-world bug bounty tasks, including vulnerability detection, generating exploits, and also patching the vulnerabilities as well. And these agents can essentially claim the monetary rewards equivalent to tens of thousands of dollars in these real-world bug bounties. So that's Bounty Bench for web applications. So in the second example that I will mention here is called the CyberGym, is another benchmark that we developed recently, including close to 200 large-scale, widely distributed open source software, and included over 1,500 previously discovered vulnerabilities. So we tasked the agents with two different tasks. The first one is to identify previously known vulnerabilities in this open source software, and also to generate proof of concept, POCs. These are inputs that actually will trigger the vulnerabilities, for example, causing the program to crash and so on. And also essentially trigger what's called sanitizers, which can actually detect that the vulnerability has been triggered. So that's the first task. And the second task is to have the agents to find previously unknown vulnerabilities. So essentially also called 0 days, and also to generate the POCs for them. So our work showed that frontier AI's capabilities in these tasks have improved drastically, even just within a short period of time. So in particular, we show that as the new model releases, we see the agent's capabilities first in solving, in finding previously known vulnerabilities and constructing POCs has been improving really fast, going from, for example, SOM 4 in the late spring, early summer, was able to find close to 20% of previously known vulnerabilities and generating successful POCs to GPT-5 actually around for high thinking mode for over 22%, all the way to Cloud Sonnet 4.5. The most recent model release actually reached close to 30%. And these numbers from with just a single trial for these agents. And in addition, what's more surprising is that the agents also have been able to discover previously unknown vulnerabilities, essentially at 0 days, and also generating successful POCs for these. And a number of CVEs have been issued by the developers after we disclosed the discovered 0 days, and also a number of these 0-day vulnerabilities have since been patched by the developers as well. Furthermore, so CyberGym has been included, for example, in the system card for the Anthropic's most recent model release, Sonnet 4.5. To serve as evaluation for AI capabilities in cybersecurity. And also, Anthropic's work showed that when they improved the budget, since we had the limited budgets from academia when we run the experiments on CyberGym, but at Anthropic, as they increased the budget, they show that the agent's success rate also improved significantly. For example, when the agents can do 30 trials instead of the single trial as what our earlier work reported, the agents actually can find close to 67% of the previously known vulnerabilities and generating successful POCs for them. And also they are able to find significantly more new vulnerabilities as well, and also generating successful POCs for them. So these examples illustrating that AI's capabilities in cybersecurity are increasing really fast. So the key goal here is that we would like to utilize the AI capabilities to help more on the defense side than on the attack side. However, our recent analysis also showed that there are a number of challenges in this area. So first, our analysis showed what we call the concept of equivalence classes is given the dual use nature of AI technology that can help both the attacker side and defender side. Unfortunately, the same capability advancements for defenses can also often help the advancements of attack capabilities of corresponding stage. So in our work, we provide more detailed analysis for these different equivalence classes across the different stages for attacks and defense. So this illustrates the challenge of having AI help more on the defense side versus attack side, given the dual use nature of AI technologies. And there are additional challenges, in particular due to natural asymmetry between attacks and defense. So oftentimes there is the following argument. And even I think throughout this workshop, also we hear some of these arguments as well. So, some of the arguments says that we don't really need to worry as AI capabilities increases. Defenders can use AI technology to discover and fix vulnerabilities before attackers, and hence we don't need to worry. So, is this true or false? Unfortunately, this actually is not quite true, given the natural asymmetry between attack side and defense side. So for example, offense side only need to find one successful attack that works, whereas defenders actually need to fix all vulnerabilities and prevent all attacks to succeed. So our CyberGym work actually also illustrates this point well. So in our CyberGym work, we analyzed different agents and also with different models, their performance for the tasks that I mentioned, for example, for reproducing the previously known vulnerabilities and generating POCs and so on in the CyberGym benchmark. So what our finding shows is that even though some agents and some models are clearly stronger than others, but however, when we compare the different vulnerabilities and POCs that the different agents and different models finds or constructs, they actually there's not a superset relation in the sense that actually the different agents and different models, they tend to find different vulnerabilities in the benchmark. And so even weaker agents and weaker models, they can actually find some vulnerabilities that were not found by the by the stronger models and stronger agents. So this illustrates that even as defenders spend more resources to try to find vulnerabilities and patch them before the attackers, even when the attackers are spending less resources, the attackers may still actually get lucky and find vulnerabilities and construct successful attacks before the attackers can find them. And there are also other asymmetries, other reasons why AI may help, may give offenders more advantage than defenders. So for example, cost for defense oftentimes can be much higher than attacks. Deploying defense, even when it works, can take a very long time. One needs to develop the patch, needs to do a lot of testing for the patch, and needs to deploy the patch globally. So for example, a lot of legacy systems today are still not patched, even when the patches have existed for a very long time. And there's estimates that the current mean time to deploy remediation in hospitals takes close to 500 days. And furthermore, as our work more than almost like 2 decades ago, and also others' work have shown that attackers can even learn about vulnerabilities and generate exploits using public information on patches, and then can exploit systems before they can be patched. So attackers doesn't even need to go find 0 days themselves. They can just take public patches to generate exploits and exploit the systems that haven't been patched. So this is just one example of asymmetry between attacks and defense. And our paper also actually goes in more detailed analysis and demonstrates other types of asymmetries between attack side and defense sides as well. So for example, attackers have much higher tolerance for failure, whereas defenders have much lower tolerance for failure. And attackers tend to prioritize scalability over reliability, since they just need to launch large-scale attacks, and even if only a small fraction of them works, it can still be a win for the attackers. Where for defenders need to prioritize and focus on reliability to ensure that the defense system mechanisms are robust and works even when there are no attacks. So given the challenges and given the fast increase in AI capabilities in cybersecurity, it's very important for the whole community, for us, to do continuous monitoring of the enhanced AI capabilities in cybersecurity, and both on the attacker side and on the defense side. And to address this challenge, we recently have launched what we call Frontier AI Cybersecurity Observatory to serve as an open platform to bring together relevant AI in cybersecurity benchmarks and to bring the community together to do continuous monitoring for AI capabilities in cybersecurity. And CyberGM and Bounty Bench are good examples. And also, our analysis showed that there is a wide gap still in terms of the benchmarks that are needed to have broad coverage of the different attack stages and defense stages for to evaluate AI capabilities in cybersecurity space. So we welcome the the community to come together to build out more comprehensive real-world, realistic benchmarks and to do continuous monitoring of AI capabilities in cybersecurity. So given the challenges that I mentioned, there's a key question: how can we actually then help AI to shift this balance, to have AI to help defenders more than attackers? So in my own personal journey for the past over 2 decades of research in software and cybersecurity, as well as the security community overall, we have gone through several paradigm shifts in terms of developing defenses. Initially, it's reactive defense, where defenders focus on detecting existing attacks and try to block them, such as detect malware and block these malware attacks. And then it shifted to proactive defense through bug finding, as what I mentioned earlier. And then finally, to the final paradigm, the paradigm through proactive defense through secure by construction. So in our paper, we also did a detailed analysis showing that the first defense paradigm, reactive defense, it can still help, in this case, AI can still help attackers more than defenders for a number of reasons. Given the interest of time, I won't be able to go into. And also, as I already explained, for the second paradigm, proactive defense through bug finding, here AI can still help attackers more than defenders in the near term. So we hope that to really help to shift the balance, to have AI help defenders more than attackers, we can enable the third paradigm, proactive defense through secure by construction. So in this paradigm, secure by design, secure by construction, this paradigm focuses on architecting and building provably secure programs and systems. This approach is in contrast to bug finding and attack detection and reactive defenses. And in particular, using program verification, this approach aims to provide formal proofs that a program or system satisfies certain security properties. And using this approach, we can provide provable guarantees of security properties of the programs and systems, and that can actually help eliminate entire classes of security vulnerabilities. Given the power of this approach, actually, largely thanks to the efforts from the formal verification community, we have entered the era of formally verified systems, where there have been many different systems, including microkernel, file system, compilers, and so on, that have been formally verified. However, these systems have now been largely deployed in the real world, mainly due to the issue that it's labor intensive to actually do the formal verification. Oftentimes, it requires tens of proof engineering years. For example, in the case of SEL4, the formally verified microkernel, to do this formal verification. And when the code changes, then the proof needs to be changed as well. In order to address this challenge, my group with collaborators has been among the first to use deep learning to help automate theorem proving. So, for example, in the collaboration with Ilya back then at OpenAI, 6-7 years back, we showed that using deep learning techniques even back then, it can help improve certain steps for automation in theorem proving. And now, fast forward, given the advancement of frontier AI, I do strongly believe that we are hitting an inflection point. In our recent paper, we lay out a roadmap to bring the community together to enable to further develop frontier AI to enable formal mathematical reasoning and program verification. And using this approach, we hope that we can develop AI agents instead of just playing games like Go. We can actually automate theorem proving for program verification. And when used in conjunction with program synthesis, we can, instead of just generating code, which has no security guarantees, we can actually now generate provably secure code. And today, people are really excited about coding agents and AI generated code. And more fraction of the code is generated by AI. But however, how safe and secure is AI generated code? With our recent work and also others' work, we show that today's AI generated code can be vulnerable. Today's AI models can generate highly vulnerable code. To address this issue, we propose, instead of just generating code with no security guarantees, instead, we can generate a verifiable code generation. Where given the task description, we can generate code and also generate specification, and also generate proof that the code actually meets the specification. In our recent work at Verna, we developed a comprehensive benchmark on verifiable code generation. And with this benchmark, we evaluate that today's agents are still not good at generating proofs and also not good at generating specs. We hope with the further advancements of frontier AI, we can develop AI agents with much more advanced capabilities to enable this generation of both proofs and specs, and also together generate provably secure code. So of course, there are many challenges remaining still for this approach. Given the issues of time, I won't go into this, but we hope that with the community together, we can work together on advancing in this direction. So overall, to just summarize, there are a number of lessons. We hope that throughout this talk and also this workshop, that people have learned. So one, AI capabilities in cybersecurity is increasing drastically, and we are really hitting a pivotal point. And also from our analysis, it shows that AI can help attackers much more at the beginning than defenders, especially given the natural asymmetry between attacks and defense. And as cost of attacks going down, we expect to see unprecedented increase in attacks. And as what we are seeing today already, attackers are using these are using frontier AI already to advance their attacks. And the world was not prepared for the pandemic such as COVID despite early warning, and attacks with assisted AI could be much worse. And here I just wanted to briefly share some of lessons that we learned from my earlier work in the domain of medical device security. So my group, together with collaborators, we conducted over almost a decade and a half ago, we conducted the first medical device security analysis in the public literature, and showed that back then medical devices, certain medical devices had critical security vulnerabilities. And back then, FDA's medical device approval process didn't even mention security. So only a few years after following our work and others' work, FDA then issued guidance recommendation on medical device security. So from this lessons we learned is that security space is complex, and frontier AI will have huge impact in cybersecurity, with a significant increase in attacks that we are seeing today already due to Gen AI, and also in the near term, AI will can help attackers more than defenders. And hence, it's important to learn from the past lessons and act now. We need to build and deploy plans to improve security posture and get ready. And also, we need to use AI to build secure systems with provable guarantees. So with that, I just want to conclude that we hope that as future directions, the community can come together to build resilience, and we need to start building resilience now. For example, as I already mentioned, and also in our analysis, we show that the current landscape for benchmarks and evaluation in cybersecurity is there's many gaps, and we hope that the community can come together to develop more comprehensive benchmark evaluation for AI capability in cybersecurity and do continuous comprehensive marginal risk assessment. And we hope that the community can contribute and work together to build this frontier AI cybersecurity observatory. And also, we need to enhance defense development, in particular, to enable provable security through AI, including verifiable code generation with provable security guarantees, and also, for example, approaches such as automatic translation of C++ to Rust to provide memory safety as well. And we also need to develop new approaches to mitigate human-related risks as well. So with that, again, we hope that the community can join the effort together on building this frontier AI cybersecurity observatory. And also, I just want to quickly mention that also we are hosting the Agentic AI MOOC, Massive Open Online Course, with over 32,000 enrolled. You can learn more at the MOOC website, agenticai-learning.org. And we're also doing a competition this semester on Agent Beats competition for agent evaluation with over $1 million in prizes and resources. With that, thank you.
Okay, thanks for Professor Song's great talk. And due to the time limit, we have one general question. So I read your amazing paper about the definition of AGI. So I think that's very interesting. So I think many audience will also want to know the question. So how do you think how many years we can achieve AGI?
I see. Okay, that's a very good question. I think so. With the recent AGI paper, we try to at least lay out some concrete definition and metrics for AGI, and it's really right. It's not meant to necessarily be definitive answer. It's more, I think, as a starting point for the community to come together to develop more concrete and also common knowledge that we can discuss together. And with this, so in the paper, we also, provide some evaluation of along the different dimensions in AGI. So of course, it's difficult to predict when we'll hit the points, but I think there is overall there's a lot of a lot of the groups. I think in general we do predict that within the next few years,
Okay.
the AI capabilities can increase drastically. That can make a huge difference.
Okay, thanks. Great. That answered my question perfectly. Thanks, Professor Dong's great talk. So our next speaker is Nico Landers. And Nico Landers is co-founder and CTO at Dreadnought. And hello, Nico. You can feel free to share your screen and start your talk.
Yeah, sure. Is it showing up okay?
Still started, but cannot see your screen.
Okay.
You can start share your screen. Yeah.
Hey, look.
Maybe we need to wait a moment to show this screen. Yeah. Can you?
How's that?
Yeah, great, perfect. Yeah. You can
Perfect.
start your talk.
Oh,
Yeah.
found the
Great,
options.
great. Yeah.
Excellent. Yeah, thank you for having me here. I thought I'd start with a quick intro. My historic background is in security as a career. So I did malware engineering, capabilities engineering, a lot of technical work on the offensive side, but blended it a lot with software engineering. And so the talk I want to take us through today is really going to cover my perspective on how software engineering principles maybe overlap in this new agentic space, but even more broadly, maybe patterns I've observed in the way people apply new and novel technologies as they relate to software in the security space. So my current day-to-day is primarily building capabilities, frameworks, and platforms for applying LLMs and AI technology to the cybersecurity space, specifically on offense. So my premise that I'm going to work with through the talk is that we're at a place now where obviously these models have been proven to be able to do the thing, whatever the thing is. A lot of people measure as like code security, could be agentic offense, solving CTFs, doing some like general analysis, assisting with reverse engineering. And the problem space we're moving into now is whether or not we can do this process reliably and at scale. And my premise is that this is actually an infrastructure problem now, not so much a skill set problem, or even a problem that's going to be solved just directly by model improvement. I think that point's been made pretty broadly, both by the Frontier group and the AICC group, which is that like the harnesses that leverage these models are actually becoming more and more relevant now. And the delta in performance is going to be driven largely by them as opposed to anything else. We also care a lot about just measuring the broad capability now. So does it actually do the thing in the real world? I think Newton from Anthropic made a great point there of, you start with evals and benchmarks, and then at some point you graduate to just caring about, in this scenario that is as close to the real world as possible, how does the model perform end to end? So when I was doing a lot of malware engineering, I taught courses on how to do malware engineering, and a pattern I saw in the space was a lot of security people, a lot of very technical ICs are really interested in the idea of writing malware because it felt like this kind of esoteric, or maybe not esoteric, but this very like specialized piece of software that was aligned with their domain expertise. And they would all start down this road of writing a piece of malware. And then as soon as they arrived at the moment where they realized it's software, it got uninteresting to them. The software itself is just framed by intent. So C2 software has almost 95% of its core capabilities with like a remote management software you would use for IT. And when you are an individual contributor or domain expert writing specific tools for your use case, you can oftentimes miss out on like bigger context, like larger context from the software space. And there's also this pattern from security where people working on these problem sets, building the software, were very technical individuals rewarded for their deep technical knowledge, as opposed to like architecting broad systems or maybe playing in this bigger process of engineering itself. So I see a lot of similarities here with the agentic software space, where there is a broad incentive to work from the bottom up with your specialized expertise. So maybe you've spent a lot of time with these models, you're really familiar writing prompts, you think about agentic systems, and you've maybe written a framework for it. And you take every novel idea you have, give it a unique label, and then kind of compete on this stage to say, I engineered it this way, and the way of engineering an agent in this multi-agent system is labeled as X, and X is the best way to do it as measured by this benchmark. But in traditional software engineering, we just do this silently. Software engineers have built the entire ecosystem around us purely off of leveraging lessons historically from each other and trying to use like shared terms and a deep understanding of what is actually going on in the system as opposed to the task-specific application of that system. So to give an example, like a container scaling system works the same whether or not the containers are doing medical operations or supporting chat apps or building games. It's a containerization system. So we find these common terms and we try to frame them as software. So what I want to take us through is this idea that eventually where we're going to end up is stochastic software systems where we treat the systems like we would a model, and we put them through an ML ops pipeline and effectively have the software self-optimize and discover the best way to present itself. So the layout I want to kind of work through here for the mid part of the talk is in this stochastic software situation, you have these blended components. So I've kind of highlighted like the orange ones here as maybe being the what we would call like more agentic systems. They're portions of our software stack where we've yielded control out to an external stochastic model. Obviously, the stochasticity is something we care a lot about. We want the system to have emergent properties because of it. But in a big picture, really what we're just engineering is software with some like novel edges. So in traditional software engineering, we don't necessarily have to deal with non-determinism, although it's a common byproduct. And we also don't typically think about writing software for use in downstream learning, which is something you do a lot in model building. So you think about the data the model is producing as something that you're going to use later to improve the system. I want to draw some analogies here for software engineering concepts into this agent space. One of the biggest lessons you learn really early on in software engineering is that modularity and the interop between components is extremely important. We have a huge amount of our technical space dedicated purely to designing these interfaces. Not only are there standards, but there's mechanisms we put in place like API schemas and expectations software can have about how it's going to pass data from one unit to another. And I sort of posit that the AI space, the LLM space slowly being brought into more advanced software architectures has been echoing that flow. So the models themselves are text generators. They complete text token by token, and we start stacking on these higher order systems like parsing, role mechanics, structured outputs. We give the model the concept of a tool, which really is just an API schema. It's like a structured format. We start putting them into actors and putting them into distributed systems. But like this is the natural flow that we went through with software as well. Most production enterprise software that you would use day to day, like SaaS applications, run on highly distributed systems that scale. They're containerized units that negotiate with each other through shared API interfaces and message buses. So like we don't need to invent new terms to describe these systems. And I also think there's a lot to learn about this overlap of like the path we are walking in this space is the same path that software engineering has walked previously. When I think about the units inside of this blended pit of software, the software analogy would be a function typically, oftentimes in workflow orchestration, they're referred to as tasks. But the argument I want to make is by small extension to traditional software, we're really thoughtful. We can start to think of these individual units as a small block of logic that in some cases will be fixedly defined. So it's software that we write via code. In other cases, it's a stochastic system where the internal behavior is going to vary every time we call it. But what we care about is taking inputs that we're going to put into this logic block, capturing outputs, and ideally measuring those outputs as well. And once we design the whole system around these unit blocks, then we can start building higher order mechanisms that are really powerful. I want to double click also on the idea of evaluating these unit blocks at point in time. So taking measurements in this system where we want the stochastic software to be part of an ML ops pipeline demands that the measurements we take are imperative. So they are defined wherever the task is defined, and we place them together. And so every time that unit of work performs logic, every time it takes an input and produces an output, we're keeping that as like a row in a data set. This is the alignment that's going to get us to the improvement process later. Sometimes we walk around to this idea by designing, say, RL environments where the scores and verifiers are kept at the environment, and we think about the actor participating in that. My argument is that having these evals in the loop is a really important part of also applying these agent systems to the real world. So in the real world, the things you find, the novel things you find, like a vulnerability in a system that wasn't previously as part of a benchmark, as long as you measured it and you've taken that as a unit in a data set, you can then turn that and feed it back into a benchmark. So we're starting to build and blend the idea of benchmarks with like real world actions. So the actions your system takes start to become data units you learn off of and also you benchmark off of later. If I take a single unit and imagine it's stochastic, so I'll assume it's running like a really simple agent React loop, then the challenge we have is that this function is relatively black box. We can think of it like a code function, which is that it has like an input interface and an output interface, but the interior logic is going to be determined by some model. And that model, the way we control that model is really relevant. And the way we get insight into what's going on in that black box is also super relevant. So in systems we build, we like to present a state that goes into this box. In the case of LLMs, it would be like a list of messages and events that occur during the execution of that sort of logic unit. And these events can then get fed out to external systems and be reacted to. And once you have that, you start to plug into a bigger software architecture where you have like actors or units sharing a message bus, where the code that's measuring the output of a task or the code that's reacting to the behavior of an agent doesn't necessarily have to be co-located with that agent, which is going to be really important when we start to plug these systems together and scale them. In software, we have a really powerful like tracing subsystem. We all, maybe familiar with like OpenTelemetry, and this is starting to get applied to the space, and that's not by accident. Ultimately, if you have a piece of stochastic software where portions of it are relatively undefined and their behavior is going to be dependent on parameters you place in, then the trace that you collect out of that system, the trace of the software stack is, in some sense, everything from a trajectory to your data set. It can be converted later or thought of later as any of the important data units you need to facilitate active learning on this process. So I mentioned here that like computational graphs are inherently DAGs, so oftentimes we get confused. We think of building agentic systems and we think of building workflows, think of workflows and we think of DAGs, but it's like writing software is implicitly a DAG. There's a flow of execution that we can capture, and ideally this execution is imperative as opposed to declarative, so that we can let the software do the things that software is great at, which is be a dynamic system that's responding to input data without having to fixedly define all of its behaviors, which is a rather immature way of viewing software architecture. In terms of improvement, once we have these units defined, we can think, especially for the agentic units, as taking in some combination of context and a model pairing, right? Those are really the two inputs that define the behavior. I maybe think that there's some analogy here of like source code. It's like a fuzzy bit of source code that we care about. And context engineering as a term, I think, has emerged because people have started to understand that that is your control plane. Like the context going into these units in terms of all of the tools and higher order elements you have being distilled into like a set of text that's going into this inference model is the way you can influence its behavior. And so controlling that's really, really functional. And even more than that, once we have that control surface, we can start thinking about all of the alignment between the improvements, like the optimization strategies and post-training processes we apply to these units of work as being a really cohesive story about their operating on the two core elements that define the behavior of this unit of work. And so these are really powerful elements that should be generalized. We shouldn't think about wanting to do optimization and then build a system around it. We should build the system in such a way that we immediately have the levers to pull during this training and optimization process, and those are well defined. We can do this partially by all the magic that code has to offer, where we can take like very rich objects that have like nested elements and kind of get a whole visualization of what is about to be a dynamic stochastic piece of software and extract out a bunch of parameters and configuration values that become the knobs we turn. And I kind of think of this as like taking elements from the software and turning them into hyperparameters that we can optimize against. To speak more specifically about some elements here, this has been mentioned, I think, in AICC, most notably. The tooling layer in the cyberspace is like really potent to us. I think wrapping these complex tools and exposing them as if they're an API, particularly the way we want APIs to work, which is like kind of stateless and very well defined, is very hard. These tools are super disparate, and my focus is almost exclusively on the offensive side that doesn't include the defensive side and a lot of supplemental tools there. I think software engineering is a very mature space by comparison in terms of the tools being extremely well defined and the tools being highly optimized to be relatively consistent in their behaviors, because that is how we construct useful software. And so a pattern we can use is treating this tooling layer, the manipulation of it and the layout of it, as another thing to optimize against. So this is a chart on the right of network operations agent that we're having run against the game of Active Directory Go environment. And you can see here, I'm looking at the score deltas when I pass different types of tooling interfaces for the same set of underlying tools to the model. So this is like a network ops agent, and so they'll have a CLI tool, and we get to choose whether or not we want to expose like general functions or specific functions, whether or not we want to constrain documentation of the tool or only give it a subset, a small aperture into the tool, and all of those can affect performance. We also care a lot about, as mentioned up at the top, just the scalability and general reusability of the tool sets, which in cyber are usually very poor in this sense as compared to software engineering. From an environment side, and this has been talked about a lot today, cyber environments are very tricky to reproduce. And I think the core reason of this is that a cyber environment, like cyber is an intent. Like what we do in security is we test integrated systems. And so by definition, when we mean cyber environment for the majority of use cases, we're talking about deploying full integrated network stacks and applications, because there is really no definition of a dedicated cyber task, maybe outside of some code analysis tasks, right? Like if I want to write an agent that is good at network ops in a Windows Active Directory network, another way I might frame that question is, can I build an agent that could manage an entire Active Directory network? What would the environments for that look like? What would the evals for that look like? And that's true for every subset of cyber. So Josh's slide where he kind of showed like all of the buckets of the variance in cyber is just going to dictate that these environments are extremely complex, difficult to build. And maybe in a sense, I'm more keen to just get straight into the real world as opposed to focusing too much on reproducing the real world through an environment, because the real world is already an environment. We maybe don't get the cleanliness of an eval in order to like reset state and kind of manage the noise in the environment. But hacking a real world app on a bug bounty is a free environment. Like that's an environment that is public that you can access, and it maybe doesn't conform to the mathematical or RL version of an environment, but it's where we want these agents to work anyways. And then the place I'll kind of finish on here is the idea that this system should be built with scaling in mind. There is a huge overlap. There's a talk from the PyTorch conference that actually Don did a keynote for, and I can't remember his name, but an engineer from Anyscale is talking about how despite the fact that there's a huge variety of RL frameworks, they all share Ray as an underlying scaling mech. And so you can see that like, despite them wanting to express all of these disparate opinions about what an RL framework should be, when the rubber meets the road in terms of infrastructure, they're all relying on really mature systems to get stuff done. And I don't think we should reinvent the wheel there either. The target state that I'd like us to get to finish this whole thing off is that we have a platform, and the platform backs observability and the artifacts we care about and manages a cluster of capabilities that are deployed at scale. And as those capabilities run both in evaluation modes and in the real world, you have this data flow back into the central platform. And we treat this whole software architecture like we do models, which is that I have a unit of capability that I can deploy and I can version. I can gather data from it, and I can take it through a training process or an optimization process later and effectively hill climb on the whole thing. And all of these problems are actually well solved in software. And I think we should lean more on thinking about the agents we're building as both units of stochastic software, but also how they plug into systems we're already familiar with, like model inference, platforms, and AI infrastructure. And that's it. I hope I wasn't too over. I'm 2 minutes past, I think.
Hello. Thanks for Nick's great talk. Yeah, maybe we can have one question due to the time up. So, do you think when will AI models surpass human in cyber security tasks? That previous
Yeah.
speaker also discussed that.
Yeah, question of the day. For us, they already have in quite a lot of subsets. I mean, an agent in our environments can hack a network in minutes that would maybe take me hours. So depending on the skill set, that's kind of already passed. And to me, the question becomes less about are they better than humans and more about how are they facilitating a process. I don't look at a piece of software and ask, is it better than me at a task? I look at the software and think about its application to a task set and a process and a team. And so I think maybe a maturing perspective for me would be like thinking of these agents as being human capable is less relevant than thinking about the systems that we build them into and those supporting like an activity or a workload we care about. And so I think the software complexity is going to define a lot of how quickly we scale that into the future. And the real world application of these systems will start to deviate more and more from benchmarks as it depends more on how people engineer the software than it does the raw capabilities of the model.
Right. Thanks. Okay, so due to the time limit, we can move to next speaker, Richard Danzig. Yeah, Richard Danzig is a senior advisor at Johns Hopkins Applied Physics Laboratory and 71st Secretary of the Navy. Hello, Richard. You can feel free to share your screen and start your talk.
Yeah, of course, I've got now a system setting challenge. Are you seeing my screen?
Yeah, you can. Yeah, no, currently no. You can share
Are you
your
seeing
screen.
my slides?
No, we cannot
Mhm.
see your slides.
Yeah.
No.
I think I can do this without troubling you to go through the slides. The world I'm seeing is very much the same as the world that has been described by the other speakers. What I want to focus on
Sorry,
is,
Richard,
Yeah,
if you want
Richard.
to show the slides, you can also send the slides to Shanding and
Yeah.
he can.
Yeah, I
he
can
can
help you to share this. You can say,
Shanding can, if you send the slides to Shanding, he can
yeah.
help show the slide.
okay.
Yeah, currently we cannot see yours.
Yeah, I can do that. Sorry.
Yeah, no worries.
So,
take your time. Yeah.
I'm sorry, Dawn, I've got your email address. I'm
You
going to
can just
send
send
it
it to
to you.
me. Yes, then
Yeah.
I will send it to Shanding.
I'll be just one moment.
Okay, yeah, no worries, just take your time. Yeah.
Sorry. That's not the right thing, Dawn. Just a moment.
Yeah, no worries.
No worries.
Yeah, take your time.
Okay. While we're at it, though, I can start and then go from there. I was going to say that the world that I'm seeing is very like the world that's been described up till now, the rapid advances that occur. What I particularly want to stress, though, is that the points that Ian made when he talked about the models can do so much more than we're actually implementing in reality. And Josh's point that a critical variable in this regard is the process and not just technology. Those points are fundamental to what I want to say. Um, I'm not concerned with the small companies so much that Ian talks about, though that's a very legitimate concern. I'm at the opposite end of the spectrum, thinking about the Department of Defense, and I want to use it as a kind of case study. And four themes run through this case study. First, the fact that really the problems are not just problems of development, they're process of organizational assimilation is a fundamental issue. And there's huge organizational, this is the second theme, resistance to these changes. that resistance is actually shaped by distortions that in organizations that, in my mind, are very like responses to weights in AI models. The organizations have vectors as a result of their own organizational weights as pre-programmed. You can see this even in corporations like the AI world that we're dealing with the Frontier Labs. Google and OpenAI and Meta are all very different because in part of the kind of corporate weights that are hidden behind the scenes. And finally, my fourth theme is one of coevolution. The governments, the future of governments will be shaped by AI. I think you all understand that, but I would emphasize as well that the future of AI will be shaped by governments. And it's the coevolution of these two systems that I think is particularly important to grasp, not just the technology within itself. This is a sort of phenomenon of as AI meets governments, an irresistible force. AI meets an almost immovable object. So what happens? So let me just ask Dawn, are you having any success there?
Yeah,
No, I didn't.
okay,
Which email address did you
make it.
send the slides to? I didn't receive any email from you. Which email address did you use?
I'll tell you that in a moment. I
Mhm.
like the way
Maybe,
we're all prepared to talk technologically about these things.
Oh, okay. Now I think.
yeah, maybe you can just send to me
Okay.
there.
I got it now.
You getting it, Dawn?
Yeah. I got it
Yeah,
now.
okay.
So let
Okay, you
me.
can forward it to
I
me.
like the way we're prepared to talk about the whole national system of AI and cybersecurity, but actually getting me online in the proper way is a little more challenging.
Okay,
Um,
Shanti, I send you the slides.
so what I just continuing so that we don't take too much time. Eventually, everyone gets there. Eventually, there's no question that there will be absorption of AI systems and absorption of cybersecurity in ways that make all that work. The question is how fast you get there. And there's a classic example of this in military matters, familiar to you all, and that's Blitzkrieg. The Germans take the combustion engine and the radio and the airplane, and they combine those three things in a new form of warfare. But what's so striking to me is that everybody has the combustion engine, the airplane, and the radio. The French have it, and they build the Maginot Line. It depends really not only on the technology, but obviously, crucially, and this is the point that Ian and Josh were making, crucially on the absorptive capacity of the organization. If you don't have that absorptive capacity, you wind up, I think, having extraordinary difficulties in getting where you need to go.
Hello, Richard.
In
Can you
my,
see my
yeah,
screen?
great.
Yeah, yeah. So currently we are kind of which
Yeah,
slides?
so if you will, I'll just signal when we need to move on. If you go to the next slide, or
Next,
you want me to do it?
yeah, we can
Can I
follow.
do it?
No,
I
you need
can.
to tell Shanding when he needs to
Yeah,
like.
which
Yeah.
slides? You
Okay,
can tell.
I'll just ask you to. If we go to the next
Next,
slide.
this way. Okay.
Yeah, you're doing great. Thank you.
Okay, thanks.
The nation states now look on AI, in my view, rather as the nation states looked on the New World in 1500. They understand that this is important. They understand what's going on matters to their futures. But they have visions of it that are akin to, oh, there must be a fountain of youth somewhere where there's a Northwest Passage. They project their own competitions into that new world, and we'll do that with respect to AI. The next slide. Um, I think if you look at what the Pentagon is doing, it's essentially caught up, I think, or not the Defense Department generally, in three aspects. One is a tendency to think AI can now be used to improve our ability to do the traditional things, to augment our capacities to find targets or do intelligence. And at some magical point in the future, everything will be different because we'll reach a stage of AGI or superintelligence. A second thing is that those organizational weights that I talk about translate into thinking about domains of combat. And so the tendency is to say, well, there are 6 domains. There's air, sea, undersea, land, space, and cyber. And the problem with this is that the 5 first domains all have an advocate for them. The Air Force, the Navy, etc., the Army, this newly formed Space Corps. Cyber does not have such an advocate within the system. And AI as a related phenomenon doesn't have something that then is generating both an argument for it in budget context, but also a career path for people who are skilled in it. If you're particularly skilled in these arenas as a young officer, you get a huge amount of disproportionate responsibility, and it's terrific from a standpoint of the individual. But then you get told if you really want to advance in this arena, you need to stop doing it. And for example, in the Navy, go to sea where there are no such billets. So we undermine both the budgetary support and the expertise in these regards. And then the Pentagon inclination is to say, well, we'll receive this as some product that we will then utilize, which dampens the ability again to understand how to integrate it and to argue for it. So the next slide. Um, um, yeah, we got to go forward, not back. It's very tricky. The next slide says essentially, sorry, I just want to go back one. Thank you. What's happening in AI that I think is so important, and all the speakers have referred to it, Dawn particularly substantially, is how the cutting edge of much of our achievement is in coding. If you look at code forces and other measures, what we find is that there's a greater immediate sophistication and aggressiveness about the use of these LLMs for coding capability than many other areas in the space of development. And that's important generally because it points to the extraordinary possibilities associated with recursive self-improvement if this can be harnessed to the development of AI itself. But specifically for this presentation, what I want to emphasize is that that speed of development that all the speakers have touched on is fundamental for cybersecurity itself. And cybersecurity is changing very importantly. And this is the way in which it is received or not inside the organizations that need to adapt to this is important, critical unto itself, but it's also indicative of what this new world will look like. The next slide. Thank you. I just want to emphasize that this isn't a matter of waiting for AGI or superintelligence. And to my mind, it's the automation of standard professional intelligence. And to me, in some respects, this is analogous to Ford's assembly line for making automobiles, except instead we're producing software. What made the assembly line for made the assembly line for Ford so remarkably important was that it proceeded 8 times faster than its predecessors, and in combining hardware, et cetera, and with that and a new organizational technology, the assembly line, you began to get something quite different than had ever been seen before. It's important to me from a national security standpoint because when you get to World War II, the U.S. capacity to have that automation in Detroit and elsewhere undergirded all the capacity we had in that military conflict. And I believe that our ability to do the same with software will be extraordinarily important. There's a good book on the World War II experience called Arsenal of Democracy. And if you think about that arsenal as software in a world that is dependent on software, where all the different other domains, the ability of our ships to function, our airplanes to fly, our spaceships, et cetera, to operate. All these things are dependent on the software systems. So if our cybersecurity systems are inadequate and can be overwhelmed, we're extraordinarily vulnerable. And conversely, if they're strong and we can automate software better than others, we can protect it better than others. And for that matter, if we can generate offensive programs that are more effective than others, we have a huge advantage. Next slide. So there's been a lot of discussion about defenders and offensive advantage. I'm not going to spend much time on it. I just want to say that a colleague of mine, Chad Heitzenrader, I thought phrased this well when he went back to a classic article, Anderson's 2001 piece on why information security is hard, and used a rough estimate of 5 errors per 1,000 lines of code. A code base of 25 million lines of code would have 1,250 vulnerabilities. The points that Dawn and others have made, Tyler and Newton amongst them, that you've got such a large base to defend, it's a big problem. It's reminiscent, says Heitzenrader, of the Wild West, where the defender difficulties were in developing the time and the cost and the knowledge to be able to create enclaves of protection, but they couldn't protect the whole area. In the long term, Heitzenrader and others on this call have argued, I think correctly, that for this reason, when things become automated, they actually function better for defenders than for the offense, because the defenders just had so many things to do that now they can do better. It doesn't mean they'll prevail, but the net addition of AI to that world is I think in the long term more positive for the defenders. But there are two critical qualifications. The first is they have to assimilate it. They have to assimilate it fast. And if you're a utility or whatever, and this software investment doesn't figure into your rate base, or you're terribly worried about what the effect is of modifying one form of cybersecurity, modifying one piece of software to protect it better, but it's interactive with others and you don't know whether it brings down your whole system, you have a strong predisposition to be slow and reluctant. Dawn's 471 days for hospitals reflects that. But the second thing that is striking to me, and the next slide shows it, is that I'm sorry, go one more slide, if you will. Is one more slide forward. One more. That's it. Is that there's an exceptional first mover advantage. If you are ahead of others in your adoption of the automated system, you have the ability to defend yourself better than the attackers can manage, and you have the ability to implant offensive capabilities that diminish their ability to attack or their inclination to attack. So your first mover advantage can be extraordinarily great in that regard. So I just want to go back one slide and suggest one way you could use that, for example, that Dawn talked about at the end of her talk, but hasn't featured in earlier talks, is the use of formal methods. There's been a number of pieces of work by DARPA on how to develop formal methods. And the basic idea, well articulated by Galois, and the website I note there, Galois being a company that's been very involved with formal methods, is that you can start to, Galois' example is, figure out the size of the hypotenuse of triangles by looking at large numbers of triangles. But if you can mathematically assess what the formula is that would calculate that, then you can cut through all of the particulars. Formal methods provides a mechanism for establishing reliability independent of the actual modes of attack. and it is being used by Amazon Web Services under the heading of automated reasoning. DARPA demonstrated it in this program, HACMS, on helicopters and the like. I've been very keen for RAND, where I'm a trustee, to invest in this area, and it is beginning to do that. Most notably, Kathleen Fisher, who ran the DARPA Information Innovation Office, has moved to RAND to try and develop this program. And I'm hopeful that Kathleen will be speaking at the next version of this session. So if we can go to the next slide and then the slide after, thank you. One more. Thank you. I want to take, just to illustrate this in my closing minutes, the idea of the improvements that are brought by AI to offensive capabilities. The ability to discover vulnerabilities is very great. And the capacity in that context to do reconnaissance and other things is substantial. But in the end, you also need something that is very context rich, which is the ability to design exploits, to harness together several different forms of attack and the like. And that's a messy environment. It's a long task. And we know from our analyses that AI is not so good at long tasks in these contexts. Next slide. In addition, if you're going to do some attack on some country in their military system in order to embed something that deters them from attacking you, you're going to need rich data about that situation. And AI systems obviously normally profit from that rich array of data, but we don't have that rich array of data in other circumstances. There's also a different kind of alignment problem that makes it hard to delegate to an AI system. A lot of the time involved in these things is deciding what are the competing equities. One enterprise in the government thinks, well, I can get good intelligence information. Another enterprise thinks that thinks that it's better to embed and not harvest the intelligence because there are opportunities, potentially in the case of warfare, it should be kept for potential sabotage. Other entities are concerned about, does this exceed the bounds of what is proper for us to do? Does it target civilians? Is it proportional and the like? These are political judgments that need to be made by humans. So the exploit dependency in these cases requires an interaction between the AI system and its technology and the humans that creates a bottleneck, if you will. So we need to develop in advance, if we're going to harvest the benefit of the AI system, we need to develop that human expertise. And these processes, a word that Josh used often, need to be improved to adapt for this. And that's critical. Next slide. So I've talked about the first mover advantage first, but I just would suggest to you, if you translate that into Defense Department stuff, you have extraordinary consequences from having that first mover advantage or not. So next slide. I worry about whether we're well positioned to be first movers or not. I worry that there isn't enough intimacy of relationship between the U.S. government and the frontier labs developing these things. We need early access to the government from these for these things so they can see it coming. And we need U.S. government capacity in terms of expertise, the human capital, et cetera, leadership culture, and improved structures and processes. Above all, we need a much more robust integration as well, or maybe not above all, but in addition, with the private sector, as for example, in my example of utilities, you can't, or the banking system, you can't let those be at arm's length as everything else is changing. Next slide. I would just emphasize in conclusion that these are not, in my view, huge step functions. They are not dependent on the coming of AGI or superintelligence. There's a kind of continuity here where there's incremental steps and improvements, as various graphs already shown today indicate. AI and AGI are not the messiah sweeping away everything before them. Rather, what we need to do is build this co-evolution, this codependency that I've talked about. And next slide. The eventual question I'm suggesting is that everyone will get there. The question is, who is the first mover and who is a fast mover? I wrote a paper on this, and I ended it by saying that this is not a wake-up call. People understand AI. The message is we've got to get out of bed and actually preparing for it. And as my last slide, I just want to show you, for those of you who are interested in hearing more or reading more about this, I published a paper in July that articulates most of this, hopefully without the technical glitches I manifested in presenting the briefing. Thank you.
Sorry, I just mute. So, great. Thanks for Richard. Great talk. So, we have just one question for Richard. So, as you say, the AI is becoming stronger and stronger, and the large language model very powerful. So, what do you say the challenges that we face, especially in national security, and how can we do that? What strategy we can do that?
Yeah, well, I think defense over time has the advantage for the reasons I've indicated. In the short term, or let me put it differently, I think that I emphasize the formal methods possibility because I think that historically the big problem with formal methods has been that it doesn't scale. We can show that mathematical proofs work well for small systems. AI, with its theorem proving ability and its processing ability and the like, should open up for us the ability to scale much more powerfully. So my intuition is that that's a path that I want to see more investment on than we've had up till now.
Great. So, thanks for your answer. So, next is the third panel discussion, and Nico will host that, right, Nico?
Yeah, thank you.
Yeah.
Thank you,
Nico,
Richard.
yeah.
That was a great talk. Yeah, I suppose there's been a couple of questions that have been top of mind. I maybe will lead with the question to Dawn, which has been asked a few times, but where are your current thoughts on AI's ability to surpass human capability? And maybe as a nuance to that, how has that changed over time? Like, you've been in the space for a long time. Obviously, maybe 5 years ago, people had, or you had your own opinion, but how has that altered and where do you sit today on the accelerative nature of it?
Yeah, thank you. Yeah, this is a very good question. And I agree with, in some sense, some of the earlier speakers' points too. I think on one hand, yes, right. I think in some sense it's important to know, right, the increase of AI capabilities in cybersecurity. That's also why, as I mentioned, we had launched this effort on Frontier AI Cybersecurity Observatory to do continuous monitoring of the increased AI capability in cybersecurity. So to that, I do right. Right, as you know, I mentioned earlier, as our work and others' work have shown, the AI capability in cybersecurity has been increasing really fast, and it is. I mean, right, there are different ways to look at it, right? So again, for example, for these 0 days that the agents were able to discover and generate POCs for in Cyberbench, I mean, these are, large scale, widely distributed open source software. One has been fast tested over a long period of time already, and also there have been a lot of human experts that have looked at this code on these software programs and so on. So in some sense, right, with agents actually not spending a lot of money, like it's very low cost to find these 0 days. It's already showing that these agents can accomplish things that even human experts have difficulty in achieving. But of course, because also AI models, this is jagged intelligence, so they can be great at certain tasks, and then also, of course, there are other tasks I think that human experts can do that agents still cannot do today. So, so I think it's right. So the answer to the question, I think, is more nuanced. But that I think that's one dimension in terms of we want to measure AI capabilities. But on the other hand, I do think you're right. Going forward in the future, in terms of the actual impact, is also important to see how human and AI combined, how they can actually achieve even greater greater capabilities and greater impact. I mean, this I think
Yeah.
has consequences both on the attack side as well as on the defense side.
Dawn, if I can get in here, Nick, is it okay if
Yeah.
I
Please,
comment?
please.
I think there's one respect in which I think the debate about superintelligence and even more about AGI is not helpful and misleading. And there's one respect in which I think it's extremely important. The debate about that's misleading, I think, is to me, intelligence is spiky. It's not like there's one uniform kind of superintelligence. And it's way more useful to recognize that, for example, in folding proteins, we're already at a stage of superintelligence, and in other things, we're not. And the arrival of AGI or even superintelligence doesn't change that, in my view. But the way in which it's really important is, I'd suggest, if another metaphor doesn't complicate it too much, I think of it as like cislunar space. Achieving AGI, or I'm sorry, achieving AGI or superintelligence is like being able to get into that area between the Earth and the Moon, where you've got a launch platform that isn't so restricted by the force of gravity. And now you can send missions to Mars and missions to Venus, et cetera, and start doing space mining and all kinds of stuff. So the LLM models have shown, I think, that if you could get, as you improve their levels of intelligence, then you can fine tune them in the ways that are specific to this superintelligence aspect. Does that ring true to you, Nick and Dawn?
Yeah, definitely does to me. I think that's a beautiful analogy of how like the general capabilities of the model create a baseline that we operate off of, and we build off of those in specific subsets. So I think, yeah, from my perspective, the last year has shown huge improvements in their ability to, not require so much scaffolding and self-manage long horizon tasks and do planning and reasoning, and all of those things are incredibly useful core skills for doing task-specific work in the space.
Not requiring scaffolding is a down-to-earth way of describing my cislunar space thing.
Yeah. Well, that's a very engineering way of doing it, which is akin to
Stick with it.
Excellent. So they give me a list of questions. I have a personal question that I want you guys both to answer. The three of our talks and us three represent sort of three distinct spaces. So like my background's in industry, Dawn is from academia, and Richard, you're kind of from the government space. And a really potent question, and maybe I'll start with you, Richard, is when you think about the value add that your subspace brings to this problem of like cybersecurity and capabilities of these LLMs at defense and offense, what is it? Like, is it funding? Is it capacity to take long shots? Is it policy? Where do you think the advantages come from the government space at moving this forward for the nation or for humanity?
Well, I think government brings some capacity in places like DARPA, the national laboratories and the like. But I think it brings funding, and most of all, I think I wish the AI frontier labs and government would think jointly together more about the regulatory challenges. I think it's hugely attractive to say now, oh, we'll just go fast and unregulated is good. And I understand the arguments for that. Um, but what I think is going to happen sooner or later is there's going to be a crisis. And it may be that there's some massive cyber attack. It may be that there's some misuse in other kinds of ways of AI systems. You can make up any number of scenarios. And when that happens, I think the move will be spasmodic and urgent, knee jerk. to intervene and regulate, it would be way better for us to think this out in advance and develop the relationship that we need between the government and the companies, and it's not as distant as at present.
Excellent. Don, do you maybe want to talk a little bit about like academia's contribution? Obviously, evals have come up a ton. Your work is extensive in the space. You have an incredible resume, but do you think about that as being the key value? Is there something more nuanced about academia that you think is really useful for this space?
I think that's a very good question. I mean, so certainly eval is an important contribution from academia, as we have discussed fairly extensively in this workshop. And I think there's even other contributions that I think academia is particularly well suited for as well. So in particular, when we talk about right, in terms of future work, future directions, like academia is in particular well suited for things that are longer term, given that industry usually focus more on the shorter term. So for example, I think we have heard a lot of discussions about finding vulnerabilities and patching vulnerabilities and so on. So these, I would say, it's more in the near term, but how we can actually build, design, and develop these properly secure systems. Of course, this is longer term efforts, but I think it's also really important for us to really, right, as my talk mentioned, to have AI to actually really help defenders. And in the past, of course, I think this paradigm has been very challenging, especially given the huge manual effort that's needed. But I do really hope that with the advancements in AI capabilities, it can actually really help automate a lot of these steps and efforts needed, and and hence so hopefully the right, these are I think these longer term thinking and approaches. I think academia is particularly well suited for carrying out. I mean, this is also why, if you look at a lot of the ideas, the early ideas, when they are still early, then it's more academia tends to play a bigger role, and then as later on, as the ideas become more mature, then industry actually can help doing the scaling part.
Nick, I want to ask you if I can, from an industry perspective, what's in my head is that, and I want to ask you if it's in yours or you think differently, is that there's a whole emerging force, which is the extraordinary proliferation of models behind corporate walls that are air-gapped or in other ways separated. And they're doing their own work, fine-tuning and developing models, so that there's a whole lot of stuff running around out there that will develop the field that it's hard for us to grasp. And some of it, for example, in biotech, may be actually very challenging because it may run the risk of creating new viruses or things like that in ways that, though the frontier labs have been historically concerned about bioweaponry by malevolent actors, these are not malevolent actors, but we may be using AI in ways that we're not really as aware of as a society. What do you think about that?
Oh, yeah, that's a really great question. I think the answer probably lies somewhere in the blend. I do think there's a risk of organizations controlling the growth of a technology that has risk with it. But I also think that over the past 2 years, we maybe started on like a really strong foot. I mean, when some of the first work I ever started doing in the space was cyber evaluations for models. Obviously kicked off by the Biden executive order, but I think the space has started from maybe a more mature place than we typically do. While not regulated currently, I think the mentality across frontier labs and across the space is that risk of these models being abused is front of mind. I think the talks here are a great example, and maybe in a way that's maybe one of the more mature thought processes in the space. Is it's been discussed a lot. It continues to be discussed. I like the pivot now towards making the models useful for something other than offense, right? There's a fear that comes with trying to avoid something dangerous, and there's a control that you gain by pivoting over to, well, if the technology is really capable and some people are going to have access to it and maybe not necessarily be public about it, then the best thing we can get started in is like getting ahead of the defense problem. And I think that was very thematic for this, all of the sessions today, of people saying, knowing that they're going to be dangerous is something that we've actually thought of for a while, and it's maybe not super valuable beyond a certain point. But I agree with the risk. I'm just hopeful that the technology has mixed applicability to lots of spaces, and that we can grow in our ability to apply it to security strengths and defense faster than its risk on the offensive side.
And it obviously has immense rewards.
Yes, yeah. Maybe not unlike, vaccine development, and all the technology that goes into that to help prevent disease is bimodal with the dangerous aspects of building, bioweapons. I do not want to keep us over. I know we're maybe 5 minutes past, and they wanted us to keep the panel short, so maybe I'll yield out to final thoughts. But yeah, a second thank you to both of you too. Your talks were great, and I appreciate your insight.
Well, yours too, Nick. Thank you.
Thanks.
Great, thank you. Thanks a lot, everyone, for your great presentations and for the panel.
Thank you, Dawn, for rescuing my slides.
Yes, that was a clutch move for sure.
No, thanks a lot for the great talks. Okay, yeah, thanks everyone. So, right, thanks everyone for the great, for the great workshop. So let me just quickly conclude. Let me find my slides.
Dawn, if you have any difficulty, you can send it to me.
Great, thank you. I'm just trying to find it. Okay. Okay, great. Yeah, thanks everyone for joining such a wonderful workshop on frontier AI in cybersecurity risks and opportunities. And this is again co-hosted by Berkeley RDI Center and Schmidt Sciences. And at the beginning of the workshop, we talked about why now. That AI agents are reaching a breakthrough moment in cybersecurity. And I think this has been echoed over and over again throughout the workshop with the different speakers and so on. And given that we are reaching this pivotal moment, there are a number of key questions for us as a community to explore together, in particular, how we can have frontier AI to help more on the defense side versus the attack side, and how we can have the community, including academia, industry, civil society, and government, to work together to take the important steps, including we've heard about building more comprehensive evaluations, the RL training environments, and also for developing AI capabilities that can help more on the defense side, including building proposed secure systems and so on, to help the society to build up further resilience, in particular as the AI capabilities in cybersecurity reaching a tipping point. And with that, we want to welcome the community to join our efforts all together with building this Frontier AI Cybersecurity Observatory, both to further build out more comprehensive evaluations for AI in cybersecurity, as well as doing continuous monitoring of AI capabilities in cybersecurity. And also, we welcome the community to join us together for the following survey. to share your thoughts and voices about the development of AI capabilities in cybersecurity and also its potential impact in this space as well. And with that, we thank everyone for joining the workshop. For this part 1, we have over 2,000 registered attendees. And as I mentioned, so we will also have a part 2. So part 2 currently is postponed due to government shutdown that impacted a number of speakers for part 2, and will be providing further updates once the government reopens for when part 2 will be scheduled. And also I wanted to quickly just share again, for people who are interested in learning more about agentic AI overall, please feel free to join our Agentic AI MOOC, Massive Open Online Course at agenticai-learning.org with over 32,000 enrolled in the series globally. And also, we welcome you to join the Agent Beats competition that just got started recently with over $1 million in prizes and resources. And also there is a security and safety track for agentic AI. So we hope that the community can join us there. With that, thanks everyone. And thanks again for joining. And also, if you enjoyed the workshop, we hope that you can share more information about the workshop on social media and to your community members as well. Thank you. Yeah, thanks everyone.